Good morning, guys. This is your second class of integral calculus. And in the last class, we have done up with two problems, one from Cartesian form and another from polar form. And today, let's deal with parametric form. Let's start off with the third problem. Find the length of an arc of the cycloid. X is equal to a into theta minus sine theta. Y is equal to a into 1 minus cos theta. So this is the graph for cycloid. See here, as you go on giving the value for theta, both x and y, you get the values for x and y, and using that you can go on plotting the curve. And this is how the graph for cycloid looks like. And here theta is running from 0 to 2 pi. To complete one cycloid, theta runs from 0 to 2 pi. And as the point moves from here, that only I've told, as the point moves from 0 to, O to A, theta runs from 0 to 2 pi. So for one complete cycloid, you have the limit for theta between 0 and 2 pi. So the formula for parametric form to find the arc length, you have root of dx by d theta whole square plus dy by d theta whole square, and you should integrate this with respect to theta between the limits theta 1 and theta 2. And there in the formula I given in terms of t. And here they have given in terms of theta. Okay, so let's move on. And for that formula, you need, let me take this one. Okay, for that formula, you need what is dx by d theta and what is dy by d theta. So here, I have found out what dx by d theta is. See, x is a into theta minus sine theta. So when you differentiate that with respect to theta, you have a into 1 minus cos theta, and that is equal to 2a sine square theta by 2. So this is a. 1 minus cos theta is 2 sine square theta by 2. And given y is equal to a into 1 minus cos theta, and differentiating that with respect to theta, it is equal to a into derivative of 1 is 0, derivative of minus cos theta is minus of minus sine theta. See, derivative of cos theta is minus sine theta, and with that minus becomes plus. So a sine theta, and that is equal to a into 2 sine theta by 2 cos theta by 2. Okay, so I'll use these two here in this formula so that it becomes root of 4a square sine power 4 theta by 2 plus 4a square sine square theta by 2 cos square theta by 2. In these two terms, you have 4a square common and also sine square theta by 2 common. So when you remove that, the left out thing is sine square theta by 2 in the first term and cos square theta by 2 in the second term. And this 4a square, when you take out of the root, that becomes 2a. Okay, and this sine theta by 2, when you sine square theta by 2, when you take off that root, becomes sine theta by 2. Okay, and this will become 1. So here you have found out what the root is. Now we'll integrate this with respect to theta between the limits 0 and 2. So the required length of the cycloid is given by s is equal to integral 0 to 2 pi 2a sine theta by 2 d theta. And this 2a is constant. I'll take outside the integration. And when you integrate sine theta by 2, that becomes minus cos theta by 2 divided by half. So that 2 comes here to the numerator. That becomes minus 2 cos theta by 2 between the limits 0 and 2 pi. That is equal to minus 4a. Okay, when you take this to minus 2 outside, that becomes minus 4a. And when you apply the limit for cos theta by 2, the upper limit will be cos 2 pi by 2, that is cos pi, that is minus 1, minus cos 0 will be 1. That becomes 8a. Moving on to the next problem. Find the length of the arc of the parabola y square equal to 4ax measured from the vertex to the point h comma k. So I should measure this length of the parabola. Okay, so here the given equation is y square equal to 4ax or y is equal to 2 into root ax. When you differentiate this with respect to x, you have dy by dx. Okay. See, this 2 root a is constant and derivative of root x is 1 by 2 root x. So that becomes root a by x. And root of 1 plus dy by dx whole square is equal to root of 1 plus a by x. And here vertex here is 0, 0 and point is h, k. And between these 2 points, you should find the arc length. So s is equal to integral 0 to h root 1 plus a by x dx. And when you take the LCM, you have x plus a divided by x. So first we'll find what this integral is. Then we'll later apply the limits. So I have considered this integral. Okay. So here, when you substitute, when you have a plus x, you need to substitute x is equal to a tan square theta. Okay. And you have done this in your PU. When you have a minus x, you have different substitution. When you have x minus a, for that you have different substitution. Similarly, when you have a plus x, you have a tan square theta. So here dx, when you differentiate this, you have 2a tan theta secant square theta d theta. Okay. So now you have found what x and dx is. We'll substitute each and everything here. So here in this term, a is common. We'll take that out and that will get cancelled. 1 plus tan square theta is secant square theta. Secant square theta by tan square theta with this root becomes tan theta by, secant theta by tan theta. Tan theta and tan theta will get cancelled and secant square theta into secant theta will become secant cube theta. And this 2a, I've taken that outside. When you integrate this, split this secant cube theta, okay, and I know the integration of this secant square theta. So I have taken this for integration and this for differentiation. Integration of this is tan theta and this I have retained it minus, I'm integrating this by parts, okay, minus integral tan theta into derivative of secant theta into tan theta. So that becomes tan square theta d theta. And in place of tan square theta, I can write that as secant square theta minus 1. And you will expand this bracket. So it looks like this. Okay. I will transfer this minus integral secant cube theta d theta here to the left hand side. So that becomes 2 times integral secant cube theta d theta. So that is equal to tan theta secant theta plus integral of the secant theta d theta is log secant theta plus tan theta. So integral secant cube theta d theta is equal to half of tan theta secant theta plus log of secant theta plus tan theta. Okay. So here, therefore, equation 1 implies S is equal to, here I have substituted all this. And one more thing is you need to substitute what is tan theta and what is secant theta. Because I have substituted for x here, right? X is a tan square theta. So tan square theta is x by a. So tan theta is root x by a. Secant theta is root of 1 plus x by a. Okay. So here I've substituted all these things and there is 2a here and it is because of this term 2a. Okay. And I'm integrating this between the limits 0 and h. I'm applying the limits here. So when you apply the limits, it will look like this. Okay. As lower limit is 0. And this is all about the second problem of today's class. And let's move on to the third one. Find the length of the arc of the curve r is equal to a into e power theta cot alpha between the radii vector r1 and r2. Given r is equal to, see this curve is in polar form, so I'm using the formula for polar curve. Okay, so given r is equal to a into e power theta cot alpha, and they have asked to find out between the radii vector r1 and r2. So you should pick the formula in such a way that the limits is for r, and you are integrating the given thing with respect to r, and that is given by this formula. integral r1 to r2 root of 1 plus r square d theta by dr whole square into dr. Okay, and before that we need to find what is this d theta by dr. So here I have found what is, see, I have written the curve r is equal to a into e power theta cot alpha, and I'm differentiating this with respect to r, so that I'll get 1 is equal to a into e power theta cot alpha, and derivative of this is cot alpha into d theta by dr. So when you cross multiply that, that becomes 1 by a e power theta cot alpha. And when cot alpha goes to numerator, that becomes tan alpha divided by a e power theta cot alpha. So d theta by dr, you have found out that is tan alpha by a e power theta cot alpha. When you substitute here in this, you have r square equal to a square e power 2 theta cot alpha, and d theta by d square is this. This term and this term will get cancelled, and you are left with 1 plus tan square alpha. 1 plus tan square alpha is secant square alpha, and root of secant square alpha is secant alpha. Okay, and now you will substitute that here in this integral. That becomes integral secant alpha between the limits r1 and r2. See, the secant alpha is a constant. So when you take this outside the integral and integrate with respect to r, that will be r between the limits r1 and r2. That is r2 minus r1 into secant alpha. This is the answer. Okay, let's move on to the last problem. It is find the length of the loop of the curve 3ay square is equal to x into x minus a whole square. So here, this is the entire loop. Okay, this is the entire loop. And here the loop lies between 0, 0 and a, 0. See, and also this loop, upper loop is symmetric to the lower loop. Okay, so it is just enough if you find the length of the upper loop. Then you can multiply that by 2 and you can write the entire length of the loop. Okay, so here given curve is written like this, and when you differentiate that with respect to x, you get what divided by dx is. See here, 1 by root 3a is constant, you'll take that, and here you'll apply the product rule. X minus a is one function and root x is another function. There you'll apply the product rule, and root of 1 plus dy by dx was, this is the formula. When you integrate this with respect to x between the limits for x, you will get the entire length, sorry, and that you should multiply by 2. Then you'll get the entire length of the loop. And here dy by dx, we have found out that. I will substitute it here. Okay, and there is a square, so I'll square it and then substitute, then take an LCM. Okay, and this 3x minus a whole square plus 12ax becomes 3x plus a whole square divided by 12ax. When you remove the root, it looks like this. Now you have found out what this root is. Now we'll integrate this with respect to x between the limits 0 and a. And when you multiply that by 2, you get the entire length of the loop. And this 2 will get cancelled, and this 1 by root 3a, that is constant and comes outside the integral. So integral 0 to a. See, 3x by root x is 3x power half, and a by root x is a into x power minus half. So when you integrate that with respect to x, you have 2 into x power 3 by 2 plus, see, x power half plus 1 is x power 3 by 2 divided by 3 by 2. This 3 and 3 will get cancelled and you are left with 3. That is how this 2 comes. And here x power minus half plus 1 will be plus half divided by half. So that is 2a into x power half between the limits 0 to a. And when you apply the upper limit, when you apply the lower limit, it is 0. When you apply the upper limit, it is 2a power 3 by 2 plus 2a power 3 by 2, because a power half into a is a power 3 by 2. So that becomes 4a power 3 by 2. And here there is 1 half, a power half. A power 3 by 2 by a power half will be a. So 4a by root 3 is the entire length of the loop. So this is all about today's class, guys. Let's meet in the next class. Thank you.